Jain students, I Ayushi Gupta, Assistant Professor CSC Department, welcome you all to the lecture series of Programming for Problem Solving. So student, today's topic is calling types of function calling. Okay, in C there is a topic under functions, that is how can we call the different methods to call a function in a program. So students, let me recall one thing about function, that we know very well that whenever we are making a user defined functions, there are three aspects associated with any function that you define in a program. Okay, a function needs to be declared, that we known as a function prototype. The function that we have created is in the form of function definition, that is under which we define the logic, that how the user defined function works, right? And now and then after we create a function, we declare a function, we define a function, we for the usage of the function we need to call it. Fine. So for calling that function, for calling a user defined function, basically we can approach two methods, that is the heading is call by value and call by reference. Okay, so there are two methods by which you can call or invoke a function in a program, that is call by value and call by reference. So in today's lecture we will be looking at these in detail one by one. So let us visualize how a function calling looks like, what happens when you call a function, what is the importance of calling a function in a program. Okay, so suppose students, in a program you have created one function, you have defined one user defined function that will be every time doing sum of two numbers that you will pass in it, right? So function name, let's say I have given as add, it takes two arguments m and n. Okay, it can be any variable that you want to declare. So I have written the function name and passed the two arguments with semicolon. This is known as function calling. A function calling looks like this: whenever you have at some part in the program you have declared and defined the function, but you need to use it. That usage, that invoking is known as function calling. Okay, so when you write this statement, that means you are calling the function. Okay, then whenever wherever the program in the program the function is defined. Okay, so let's say how the add function works. Whenever you call add, it will return you the sum of a plus b or any two arguments that you have sent. So the function definition looks like this. Function works as, we have defined here the working of this function. So these two arguments, when passed in this function, they return us every time the sum of these two values. So when we call a function, the function name is corresponding to the function definition name, right? It maps to the function name that you have called, and the arguments that you have passed from your function are mapped to the arguments that are defined in the function definition, right? So from function calling, we pass our arguments that we want to work on, and with this the function definition works, how this function works, and computes the result and returns us the value. So this is the visualization, a little visualization of function calling when a function is called. So a little terminology is here. So students, when we call a function and pass our arguments to work on, these are known as actual parameters. Okay, so actual parameters are those values that you pass in a function during function calling, where you have actually defined the function, the working of the function, and there you have mentioned the arguments in the function definition. Those at that place, these arguments are known as formal parameters. Okay, so this is the terminology used in function calling. So students, after this visualization of function calling, we are going to discuss call by value method. The very first method of function calling is call by value method. So what happens in call by value method, students? This is one of the method that by using which you can call the function. So in call by value, when we are passing the arguments, okay, and the what we have seen that the in actual definition of the function, those arguments are mapped with the formal parameters. Fine, student. So what happens during call by value is the arguments, the actual arguments, their values are copied to the formal parameters. Fine. Let me again set the slide. So in function calling, the arguments are actual parameters, and in function definition, the arguments are known as formal parameters. So what happens during call by value is when these arguments are passed to the actual function definition, the actual parameters are not exactly passed, right? During this process of function calling, what happens is the value of m and n, or you can say the value of actual parameters, are copied, and those copies are passed to the formal parameters. So in call by value, what is happening is our actual data is not going, right? When you are calling the function and you are passing the data to work on, the value inside those variables are copied and passed on to the formal parameters. So in this way, whenever any manipulation takes place according to the according to the function definition, that will not be affecting our original variables. So this method is known as call by value, that we are creating the copies of our values that are associated with actual parameters instead of passing on the actual variables, actual memory locations we are not passing, but we are utilizing the values that they are carrying. This function that we have defined will work with those values that it has got during the process. So call by value is the default method of function calling. Whenever we have called any function, whether it is user defined or system defined functions, what happens is it is actually copying the values, copying and passing the values only instead of passing on our original data, right? So with this method, students, our original data is not manipulated. Our original data is every time saved, and we can use the values as it is of original variables, even if they are modified by the called function, because they are getting the copies of our variables, not the original values. So let us try to understand the call by value method with the help of one example that will help you to understand what exactly is call by value. So students, to understand this method, I have taken one example. In this example, I have taken one number, one variable carrying a number value, right? Say any, I have taken 100. Okay, in this program, I will be making one function and passing on the value of this number which I have taken to the function which I have defined somewhere in the program. Okay. So when the function that I have created, or a user defined function by me, will be having this will be having not this original number, but it will get the copy of the value that I will pass on. Okay. So then what happens is when the call function will get the value, I will be doing some manipulation. I have put some logic to manipulate the value of that number. After the end of this process, after the function is called and it executes, there will be no change in my original number that is the part of main program, right? So let us try to visualize and understand how this program and ultimately call by value is working. So let us have a look at the main section of the program. So students, here I have taken one main, I have called main function, and under this main function I have taken one variable x. X is having the value 100 at some location, let's say 1000, right? I have printed one message here, printf before function call x is this. Okay, so this I have done because after the end of function, the value of x will be changed, but to see that whether the original value has changed or whether the change has taken some place in the copied value. That's why I have printed this message. So before adding value inside function num is equal to 100, this I have printed. Now I have called one function which I have defined with the name change. The function name is change here, right? So I have called the function change, which I have already declared in the global section of the program. So the function defined as change function having return type void. It takes one argument. I have declared the argument as integer num, right? You can take any variable name. I have taken as num. Now how this change function works is, in this function also I have made the message clear so that the user is able to understand the difference and analyze that the value has taken place in the copied values only. So inside this we have printed message printf before adding value inside function, because we are doing some manipulation here. So I have printed the message as before adding value inside function, the value of num is this. So when you are printing in the very starting of this function the value of num, when no change has taken place, so it will fetch the value num. So student, what happens here? I missed one point here. When we call the change function from here, when we call the change function, so the compiler looked for the definition of this change function. So we have declared this function in the defined this function in this program only. So change is mapped to the change that we have defined in the global section, and there we have taken the formal parameter as int num. So int num is also created. Fine, because it is the argument of this function. It is, we have declared it. It will be created at some random location, let's say 2000. Fine. Now change is mapped to change, and then what happens is the x actual parameter that you are passing here to the formal parameter num, during this process it copies the value. Copies the value of what? The argument that you have passed. Here we have passed x. Copies the value of x. So again, when you have called the function change and you have passed the actual parameter, and change is having its own formal parameter in the function definition, so the value of x is copied to the num variable or formal parameter of this change function instead of passing on the actual x, right? So from here we can also visualize it as this x is passing the copy of its value. So the x actual parameter is passing the copy of the value inside it. So what is the value of x? 100. So x there is also 100, and to formal parameter num it is also passing. It created the duplicate copy of this x variable, that is 100, and that is stored in num now. Fine. So when we printed this message before adding the value inside function num, it fetched the value from its num only. Of course, it is a global function and we cannot access the x here. Okay, we can pass on the value of x, whether copy or original, that we will see, but you cannot access the x in change function as long as x is not global, because x is having local scope here, so we cannot access x value there, right? And of course we have called the call by value function, which the nature of which is to copy the value, not by passing the original variable. Fine. So before adding value inside function, num is printed as 100 because num got the copy of x variable. Now inside the function what I have done is, I have done the manipulation is num is equal to num plus 100. Num is equal to num plus 100. So in memory location the value of num is 100. and we are adding another 100 to it. So the total value is 200 that is assigned to the num. So now the num is 200. So students, after this statement, I have printed the messages after adding value inside function num is equal to this. So now when you are trying to print the message having the value of num, so now look here, the num variable value is now 200 because of your logic or because of your manipulation that you have done there. And notice that, okay, so this statement is printed. When you come back to the function statements are no statement is left to execute here. All statements we have executed. When the function returns back to the main function, the one message that we have printed here is after function call x is equal to this. So students, notice here when you are trying to when you have printed the value of x, it is printed as 100 and you pass the value of x in change to num. So what happened, because the default call by method of function calling is call by value. So what happened is when any change that you did in change function, that didn't affect our original variable x, right? Because during this process, as we have discussed, they passed on the copied values. They created the duplicate value of their variable and passed to the variable or formal parameter. So any change, any manipulation that took place in the copied value only without affecting the original. So you can analyze from this output as before function call x is equal to 100, before adding value inside function num is equal to 100, or you can change in the message also as x, okay, because you are just printing it and x is the value from num you can do. After adding value inside function, of course, we have changed it as 200 and now we are having the original value maintained as it is. No one is able to access or affect the original value. It is as it is and we have also successfully printed it. So students, this is one of the method of calling function known as call by value. This is how call by value works. The normal function calling that you do, it works like this only. So any function that we call in the programs, so they copy their values to and pass on to the formal parameters during function calling without affecting our original variables. So let us have a look at another program to understand completely the process of call by value method. In this example, very important program of swapping I have taken, and this we have done using call by value method. Okay. So let us recall the concept of swapping. So swapping is when we have two variables, when we have two values, let's say A and B having some certain values as 20 or 50, let's say. Okay. So A is having value 20 and B is, let's say, 50. So the container variables A and B are having some values, okay, and somehow if we are able to exchange their contents, manipulate their contents in such a way that the previous value of B is now contained in A and the A contents are given to B variable, okay, maintaining their original address location as it is, their name will not be changed, but their inside contents are changed, or we can say swapped. So this is known as swapping. So for doing this, we have made some function. We have created a user defined function, and with we will be able to analyze here and see the working of call by value that has taken place here without affecting the original variables. So let us look at the main section. In the main function, we have taken two variables, integer a and b. In we have taken the value of a and b from user with the help of printf scanf. Then, so the user has entered 20 and 50. Okay. So to see whether the effect has taken place in originals or not, we have printed one message that before swapping A is this and B is this. So the original values of A and B are printed on the output screen. Now for doing the swapping, for doing the logic of swapping, we have called the function swap. We have called the user defined function swap here. So when the function is called, the swap function is called, the compiler will look for the definition of this swap function. So x and y, the formal parameters are declared in the function definition. Okay. So a and b, 20 and 50. These values are copied to the corresponding formal parameters x and y, which are the formal parameters of this swap function. So the copy of a is 20 is copied to x and b 50 is copied to y. Okay. Now the logic of swap is, we are using here the concept of swapping using third variable. So for that I have taken one variable temp here of integer type. So we already know the swapping by third variable. So this I have assigned first the value of x to temp variable. So the value of x is fetched from here, that is 20. Now x is equal to y. So y value 50 is given to x and temp value that we wanted in y is now 20. So students, after the end of this process, the x and y variables are having the swapped values as 50 and 20 respectively. So from here only, because we have done the changes here and we will utilize these copied values manipulation to print the result. Okay. So here only I printed the message that after swapping A and B is, see students, in the print statements I have taken A and B. Okay. So you cannot say here that we are not able to access A and B because it is in the print statement only. I am not accessing the value. I will utilize these variables of swap function only. Just I have printed the message in quotes, in double quotes. When anything you want to print, you can write, right? So A and B will be printed in the statement, and from where I am fetching the value of A and B, I have utilized this x and y because I cannot access A and B here because A and B are not global in my program right now. Fine. So from A value is coming from x, B value is coming from y, right? So look at the output that after swapping, this is printed from the swap function. After swapping, A is equal to, it is coming from x. X what we have done is 50. B is equal to, it is coming from y. Y what we have done is currently now 20. And now look at the complete output that enter values for A and B. A and B are 20 and 50. Before swapping, A is 20, B is 50. And after swapping, A is 50 and B is 20. Okay. With output with which we were concerned to swap the values, that is very well reflected in this output. And we have utilized the swap user defined function that we have created as with the name of swap. Okay, so we called the function, and during this function, this is a default function calling method call by value. They copied our actual arguments of A and B and passed the copies to the formal parameters x and y that we have declared in the swap function. Any manipulation we did with the help of third variable temp to swap the values took in the formal parameters only, or you can say the copy of values only. A and B we have not touched here. Okay, so with this method your original variables are completely safe, completely unmanipulated, and whatever change you want to do, you can copy the value and pass on to the called function. Okay, so this is how the default call by value method works. So the second method of function calling is call by reference method. So students, let me give a brief review of call by reference, then we will understand with the help of example this method of function calling. So students, call by reference means addressing. Okay, reference is related to here as address of variables. So the heading is call by reference. That means you are calling the function on the basis of reference. Okay. So what is happening in function calling? We put the name of function that we want to call. We pass some arguments that we want to work on, and those are passed on to the formal parameters of where you have defined the function. Okay. What happened in call by value? Your arguments values were copied. Okay. You pass no reference, no address, just the value inside those variables were copied and passed. In call by reference, you are making the reference or address of variables as the basis. That means somewhere calling is made with the help of those address of variables are also involved, right? The address of variables where they are actually located, those are involved in the calling now. So how this method work? What is the aspects of this method of calling function? Let us try to understand. And students, to understand completely the concept of call by reference, we need to understand pointers. Pointers concept is very important, and it is the basis of, you can say, call by reference is pointers only. Without pointers there is no call by reference method. So let us recall the concept of pointers. So pointers very well know are that pointers are special variables that are capable of storing the address of other variables inside it, right? They are unlike normal variables in which you store the values of any data type, but in pointers you can store the address of other variable data types. So the syntax of pointer as the data type of which you want to store the address, the data type you mention, then this asterisk symbol to mark as pointer. This is the identification of pointers, and any variable name that you want to give, you can take. Okay, so you can write the pointers as, you can declare the pointers as in these three forms. Let us take some points here, that if I want to declare in the program 3 pointer variables, so I have taken as P1, P2, P3 because they are pointers, so I have marked the star here, and they will be storing the address of integer type variables. So all these pointers are integer type and I have declared them as int. Okay. So this is one of the method, or with data type you can mark the star and write all the variable name. This is also fine. So these are some note points here that related to the syntax of pointers. So let us take a look at the very small example of pointer working. So in this example, let's say I have taken one pointer variable as ptr. There is another variable a, integer. A is having the value of 10. PTR we have just declared it is currently empty. Now we have declared the statement as star PTR is equal to AND A. So AND is ampersand for address of variables, right? So that means that PTR is storing the address of A. You have declared the PTR as pointer variable, fine. A as normal integer having value 10, but inside PTR of which variable you want to store the address, that we have declared in this statement, fine. So this signifies that PTR is storing the address of A variable. So so the address of variable A is 2000 and this is the content of PTR. Okay. So now some printf statements here. If we are trying to print the value of PTR, it will be 1000. Oh, sorry, it will be in this example I have taken as 2000. So here 2000 will be printed. So printf is basically what is the inside content of those variables that is printed. So PTR is having address of A, so that will be printed. In this example, I have taken 2000. So 2000 will be printed. Printf A, the value of A. What is inside A? Inside A is 10. So this will be printed. When we are when we are printing star PTR, that means the value at the address inside PTR. So the value at the address inside PTR, 2000 address is inside PTR and the value at this is 10. So that's why 10 will be printed. When we are trying to print AND A, ampersand A, so that means ampersand is address of. Ampersand is address of and you have written A and address of A is 2000. So 2000 will be printed here. So these are some terms and symbols of where that you will be using in pointers, and pointers we need very important concept to implement call by reference method, right? So that's why we have recalled the pointers concept here. So let us now try to understand with this example how actual call by reference works and how to use the of what points you have to take care during function calling by reference. So students, let us take one example. In this example, I have taken two integer variables as x and y having values 10 and 20 that can be visualized as this. After this, I have called one function fun, user defined function, fine. It takes two arguments. Function takes two actual arguments. These are the actual arguments of my program that I want to pass on. I have taken x and y. Students, inside call by value method, if it were call by value method, I had simply called function and passed on the actual formal parameters. Yes, actual parameters as x comma y. But since I want to do it on the basis of reference, the reference I need to pass. Fine. So when you want to signify it as call by reference, we have to pass the reference. Reference means address of variables, and for address of variables, symbol uses is ampersand. Fine. So instead of simply writing x and y, I have called the function and passed the arguments as ampersand x and comma ampersand y. What will happen when this fun function will be called? The compiler will map it to where the function is defined. So we have defined the function as fun okay. So formal parameters are also two parameters. So from behind we are passing the address of x and y, and inside informal parameters, those actual parameters will be coming from behind, and from behind you are sending the address. You can not write the normal variables here. So, and we know from our previous knowledge that to store the address we need pointers. So the variable that I have taken here as ptr1 and ptr2, I have made those as pointers. Okay, instead of normal variables that we did in call by value, we will have to make these formal parameters as pointers, students, because you are passing the reference during your calling of function, right? You have signified that m%x and m% y. That means you are passing the address, and to store, to catch those address, you need pointer variables. So in formal parameter also you need to make these formal parameters as pointer variables. So the function definition is, you have taken two pointer variables ptr1 and ptr2. You can visualize it as like this. So with this, the address of x and corresponding address of y will be stored here. What we are doing inside the function, the logic that we have put, for example, let's say star ptr1 is equal to 20. Whatever manipulation we will be doing with the help of function only. So I have written some logic here. You can write any statement by which you want to change these values. Okay. So now ptr1, ptr2 having address of x and y. We want to, of course, the change in address is meaningless. We don't want to change any address ptr1, ptr2. We cannot we will not be manipulating. We want to work on x and y. And to x and y, with the help of reference, we have to use the syntax star ptr1. Because what we did in the previous example, that when we write star pointer variables, that is break up as value at the address inside, right? This I showed in previous example. So with this pointer, we will be accessing the value of x and y. So star ptr1 signifies that value. Now we are reaching the value with the help of reference. So value at the address inside ptr1. So what is inside ptr1? 1000. What is the value at 1000? 20. This is the breakup of this simple ptr1. So with this we reached here, and now we are saying that, okay, sorry, x was earlier 10, and with this statement we reached x and we made it as 20. We assigned the value 20 in this. Right? So star ptr1 is equal to 20 means that value at the address inside ptr1, value at the address inside ptr1 is now 20. Similarly, value at the address inside ptr2, that means inside ptr2 is 2000. Value at the address inside 2000 is now 10, which was earlier 20, it is now 10. So final visualization of this process is, after we come back to the function that we called and we printed the value of x and y is now 20 and 10, which were earlier 10 and 20. So students, try to understand and summarize here that now you are calling the function on the basis of their reference. With reference, with pointers, you are reaching directly to the original value. Pointers are just capable to store the address. With address, you are actually reaching, you are actually able to access their original location and their values. Inside this function calling, what logic simple I have written, with this I was able to locate the actual variables. Instead of getting the copies of some values that we that we discussed in call by value, we are just reaching directly to the original and doing manipulation there, as you can see here. Okay, and the syntax that we took with the help of pointers concept. So for, of course, call by reference, we need to pass the reference that we have done in the form of x and y here, %x and %y. When you call the function, because you are passing the address, so need pointers to store them, so that's why we made the pointer variables. And we did the manipulation because by using this only you can reach the original variables, so you will have to write this as this. So this is the concept of calling call by reference method of function calling. So the final another example of call by reference method is the same function the same program that we did in call by value to change the value of some number. Now I have done this with the help of call by reference. So inside that in that program call by value, with this the copy of original number was passed on, and any changes that took place there in the copy only without affecting the original. Now the program in this call by reference, I will be passing the reference of the original variable and any change that will took place in the original variable only. So in main function, I have taken again the x variable as 100, same example, same everything, but now with the help of call by reference. So let us come directly here. So I have called the function change and passed on the reference of x. So let's say if x is having value 100 at the location 1000. Now change function is called, and there I have made the pointer as pointer num. There I have declared the formal parameter as pointer num because I am sending the address. So if you are sending the address, you will have to write the formal parameters as pointers. So this is a noteworthy point here. You cannot write a normal variable in the called function. So in that num, the address of this x is passed, that was 100 if we say, so 100 is stored there now. Now the manipulation logic is also same that we did in the previous example. Now num is equal to num plus 100, but since num is pointer, and to access the value stored at the num address, we will have to write it like this only, as we have just discussed in this previous example. So we have write star num is equal to star num plus 100. So with this star num I have also written here, with this, because of this star num, it will be read as value at the address inside it. So value at the address inside num is 100. With this statement we reached 1000 value is 100. So 100 plus 100 is 200, and that is assigned to star num. Again value at the address inside is, so with this we reached x and it is now 200. Fine. So after this we come back to the main function, and then after function call the message will be printed, and now the original value of x is changed, which you have utilized here, and 200 will be printed. So student, this is call by reference method, in which we will be passing on the reference of our original variables, and any change that we will that will take place in the original variables only. So this is call by reference, in which pointers play a very important role. So if you want the manipulation to be done in the original variables only with the help of called function in the terms of actual and formal parameter passing, you can go for call by reference. And if you want just to copy the and pass on the value of original values, copies of original values without affecting the original variables, then you can you can go for the default call by value method. So I hope you are able to understand the types of function calling. Thank you so much all.